Hey, I want to talk about cy-spok because we just found out that it can work with Cypress and TypeScript. It's whether something to do with the a recent version of TypeScript or Cypress and or both, but right now it's working with TypeScript. Then all you have to do to make cy-spok work is okay, you install it, and you don't have to. Of course, it doesn't have types, um, but so you don't have to do anything there, and you really don't have to do anything with your index file either, or um, your support and index file. Nothing. You don't have to do anything with those. So it's kind of like recurse. So you just import it at the top of your spec file. That's all you need to do. Install it and then import it at the top of your spec file. And so it wasn't working before, but it started working, and it's next level. But to really appreciate it, you got to start simply. So here's a simple example. Let's say you have a test. And by the way, this is a full TypeScript project with all sorts of setup, and I'm going to link this the repo so you can take a look at that. Well, let's say you have a test and it's all deterministic values or values that you're asserting, which you know from the context of the test. Let's say you have some fixed values, you got a person with first name, last name, everything is deterministic. You have this, let's say you have this shallow property, which would be the age, and then you have deep properties, which would be something like your name, first and last name. And you have a clone. Okay. Testing shallow properties is quite straightforward. So you can spot check, which is the most primitive way, which is what everybody does. Or you can check shallow properties with deep include, with deep contain, have contain, or contain. These two are aliases. They all work the same way. You can alternatively, instead of deep include or deep contain, all these, you can just use spok. So you just should, and then chain with a spok, and then slap it. So it's a little more concise than your regular approach to checking shallow properties. Okay, so if you compare that to deep property comparison, right, you can spot check like this, each property one by one, which is really, really boring. So I don't like doing that. But if you want to check deep properties, you got to use deep include. So none of the others work, right? They will most certainly not fail. Look at that. Oh yeah, deep contain works apparently. Have contain doesn't work. So deep include, deep contain are fine. Have contain or contain is not going to work. There you go. Yep. So you can try that for yourselves. So checking those deep properties, you can also still use cy-spok without having to worry about it. So deep include is preferred, obviously, and you can use spok interchangeably when all these values are known values, deterministic known values. Full clone, same kind of a deal. You can use everything, or you can use spok. So spok, if you have deterministic values, it's not that useful, right? It's the same thing. You already have everything built in. You don't really need spok if you know these values from the context of the test and they don't change much, or they don't change at all. It really shines when you have non-deterministic values. So what does that look like? So let's say you have this person object, and I'm using Faker for most things here. Only a few things I'm not using Faker just to demo some of the capabilities of it. But yeah, all these random numbers, random address. You have some. This is also a constant one just to demo a capability. So this one's a quite random array, and an array of object, which is very frequent in any API, right? An array of objects. Anyway, let's say you have this complex object and you want to make some assertions. With the base assertions, you can check that the value is not undefined, right? It just exists. That's all we can do. And you can check only your shallow keys or a subset of your shallow. So you can basically say like this. Let's see, only, and then start the other test. So if the values are not known, when things are non-deterministic, you either have to check that this value exists, right? We can't really check for a fixed value because it changes all the time. Yeah, this is deterministic. Right here, yeah. Or you can check the keys, would include all keys. And you can only check the first level. So here is checking name, age, and all those other things if you want. It can be a subset that you're checking for, but you really cannot check assert any of the values here because they're different every time, right? How are you going to do it? Just to note, let's say this is again only the first level, so you won't be able to assert some key from a second level existing. Right, so if I add street here, I think street is there also. Street there. No, it's not there, so it's not going to take that one, right? But like frequent whereabouts, that could be checked. So until now, this is what we've been doing, right? We check the properties and the existence of the keys, and then some fixed values that they exist and everything. So those are the limitations of the base assertions. And this is where cy-spok is helping us. If you have non-deterministic values, everything's randomized, like you see here. Let's see what we can do. So here's how it checks numbers. So we have all these. I put everything up there just so it's like a complete example. And so all you do again should, right, and then use chain with Spock. That's all. So let's check these one by side. So should and then Spock and then an object with options. And then it asserts every single property there against these satisfaction conditions. So age should be between the range of, let's make this a little bigger, 0 and 30. And if we can maybe look at it at the same time over here like that, that's much better, right? Right. Okay, so age should be there. Height should be a type number. You can also make number assertion, type assertion like this one. Greater than equal to 10 for whatever. I just came out with things here. Head circumference, just to show that you have greater than equal to, greater than, less than equal to, and you have or not equal to, right? IQ not equal to 5,000. And you have assertions around 0, greater than 0, greater than equal to 0, less than 0, less than or equal to 0. So those are your number assertions. Okay. And then you got some string assertions. Let's say you have this name object here. So you just chain down person.name. String, again, you got types. Yeah, you got your types. And the you can always use regex with string, which is, I think, quite powerful. Or you can do starts with and ends with. So here we're checking that this starts with Fred without getting too long. Let's see, let's find that part. Yeah, we see naming helps here because the list gets long, right? And then, here we go. And every time, right? Every time we start the test again. So it was string was Taylor over there. And here it's going to be Rihanna, right? So it's always going to change because they're random. But you can still make an assertion, I guess, that it's a string and it's of a certain type. And maybe if it's like a somewhat certain string, you can make a regex assertion all the time, like let's say an alphanumeric character. So you can check that it's an alphanumeric character. So that regex part is quite powerful there. But otherwise, it has these. Let's look at, yeah, regex. Regex is, so defined or undefined is quite easy, right? So let's look at this regex undefined and defined right here. So being undefined or defined is quite easy. Well, regex, of course, you can go pretty crazy. So I think this is, I didn't write this, of course, this is insanity, but this is basically a regex for address that I just copy pasted, just to show you how strong, how powerful that could be. So that's person, that address, and we're verifying street, street with numbers, city, state, all these things. See what do we have here? Spok array. So we got a few things for array. The number of array elements. You can check that. Let's see. All right, I'm gonna make this a little smaller for real estate. There we go. Array elements. So we have, what do we have here? So this is person and array. Okay, an array. So it has, so 20 to 30, of course, it's going to have 10 array elements, right? But this is a little trickier. So we have this array, and the range can either start from 5 or 10, and it can end at 15 to 20. So that basically says the range should be something between 5 and 15, right? Can be 5 to 15, anything in between. So that's a nice case of checking something non-deterministic. Um, the Now this is where it gets interesting, right? So you have this array object with array with multiple objects. You can just check that it's an array, but I think it's a little more interesting. And this is how you would check, by the way, objects. So let's say you have this, you're checking this address object, that it's a defined object, it's a type object. So those are simple. But the one that I really like, and let's say, yeah, array of objects, you got this Spark. So you're checking this guy. You can just pass a predicate function, right? It's that part is really powerful. So you could have something like, okay, let's just have it. So array of length 3. So that's quite simple. But you can go a little more complex, right? Let's say you have this array, and then array street should not be null or undefined. So that's what it's saying, right? It should not be null or undefined. But I think even better is you can just pass an assertion, right? That's the best part. Like you can just expect array map, like so yield a street and expect that to be a string, or make different kind of assertions with it. So that predicate is really powerful. That's I really like that one. So far, regex and predicate, that those are really cool. You can do so much. Of course, everything else is really cool. It's a lot better than just checking the property and checking fixed values. But those are just taking up a notch. But this is my by far the favorite part though. Let's say you took this, you took person, and then you check whereabouts. But then, let's say this isn't enough for you. You want to do more about this array of objects. So you yield that property with its, and you can mix and match with other Cypress chainers. Like let's say it has a length of 3, fine. And then another Cypress chainer, which is each. So this will check each one of these separately, obviously, right? Let's say each one's a location. We just name that. And we're in this context, and then we just wrap it, okay? And then basically we're checking once we have wrapped it, and we're chaining with should, we're asserting each one in isolation. So array of objects. So let's see, array of object. I mean, it is an array of object, but object in the array would be in the array. So this topic property is just custom, just so it makes it easy for you to read. All right, object in the array, right? And this is basically a copy paste from our address assertion up here. But the key is that it will go to each one and make that assertion as you see here, right? This random street number that it came with satisfies this regex, and then the city property, whatever the city value could be, those are also satisfied. So the superpower of Spark is giving you these um, assertions, these satisfaction conditions, without having to need to check specific things. I also left the original docs here from Gleb, and in the README there is a link to Gleb's site, and then the original Spark library, and then the installation instruction for this. But moving on, okay, how would you use all this in the real world? So I thought that'd be a cool example. And if you are not familiar with cy-API, it's just like cy-request, but it gives you uh, a very neat view of everything that you would see on DevTools. It's mostly for CI. I mean, you have your DevTools locally, but if you're API testing and you're running things in CI, it's really awesome. So let's just run this first test first, okay? Not even get into the second one. We'll just collapse this for now, just to make it less complex. So we're gonna test the Pokemon API, right? Let's just expand this, okay, and then set this up, and then we can see all the stuff. And then maybe we even open DevTools and then put it in the bottom, maybe. No, let's put in the bottom. Have some space here. Okay, good. All right. So, all right. Let's say we're just getting one Pokemon. Okay. And it's like this. Okay, perfect. The API call is just like get, and I set the base URL as the Poke API base URL. So we're getting Pokemon one. And I love this property because it's just going to automatically retry if something doesn't work. So we just yield the body of the Pokemon. So let's just look at that. Let's see. Pokemon one body. And what gets yielded looks like this. So it has a few properties. It has abilities, basic experience, form. So it's quite intricate, right? Usually what you get is something like this in the real world, lots of data. Anyway, so we yield that and then we start making our Spark assertions on it. And as you see, I'm basically just mirroring whatever data we have in here. So I just named it Pokemon top level. Right? That's where we start. And here's our assertion with the ability. I'm just going to keep this part open just so you can follow. So abilities should be an array. And oh, basic experience. I don't have it in there. So we could just add that. So is this a number? I'm guessing that's a number. So let's just add that. Abilities, base experience, spot number. Is that okay? Let's see. Oh, perfect. Since we're checking so many things, you're gonna get a big list here. So bear with that. So that's the number, and you could even check it should be a number greater than something or less than something. All right, and then forms is say it's an array. What else we have? Game indices, element range. So everything that I was showing in the previous test, we're just using those tools to make assertions about real data here. So height, ID is default. Type boolean, let's see. Location area encounters. Look at that. Yeah, so basically it's saying it should start with this, right? And you might be using this kind of thing often. Moves. Let's see. Moves should have more than 20 moves. So this has 78 moves. Let's see. Name, order, find past types. It's it should be an array. So that this is a predicate there. So this one is either array of 0 or more than 0 because some Pokemons I think have that array being populated. Let's see what is cool here. This is interesting. Sprites, whatever that is. Sprites. So it has a few properties, and we can make an assertion about saying, hey, expect this to have property front default. You could make you could just with the predicate you could just make that assertion in there, which is so nice that you can just intermix a assertion and a predicate like that. Types. This is kind of interesting. So you got two things in the types, slot 1 and 2. I guess this is like the type of the Pokemon, grass and poison. So types, and then we yield that type dot name should include poison. So basically we're checking this property. It should include poison, or it could be, I guess, grass. But see, this I don't really like because probably a different Pokemon is gonna have uh, a different kind of power, right? It's just gonna be a different kind of thing. So we should make that right. Should not be Undefined, is that a thing? Yeah, that's a thing. So you got to make a choice between, hey, do I want to be so specific with my tests, or do you want me to just relax enough so it doesn't break too much, but I'm still confident that things will be okay. Let's see this weight. Weight should be something greater than 0. That's okay. And then what do we wait? Stats. Stats is important. Stats. Okay, so stats, we're basically saying here it should be a array of 6 elements. But then stats, since it's an array of objects and almost, I mean, those are always interesting, right? So here's an example of how you can go deeper, just like we did before. Yield the stats, intermix your Cypress assertions if you want, and then we are going to go and check each. So we wrap each stat that's yielded out of here, and then we have stat-specific assertions. So we call that each Pokemon stat, and then you can just find that over here. So each part, and then this is where we got the stats, right? And then this is where the checks are doing. So you'll see 6 of these because there are 6 different stats. I will just take a look at the yield from the stats. So it should have a base stat that's greater than 0. Okay. Effort should be greater or equal to 0. The more interesting part is, again, it has another property called stat. So it's got name and URL, looks like. So let's see. Here we have 2 assertions, and we're just changing it because it's a predicate at the end, right? So we can just chain it with an and then. So object name should be a string, and URL should include that. Again, perfect. So how do we know that this test isn't too specific, that it would like work in other places? Because if you run this function, get PokeCount, and hit the API with all the Pokemons, right? It's about more than 1,000. More than 1,000 Pokemons. So what I did was I tried to make it a little simpler. Okay, how would I make this a little reusable? I named some of them the top level properties. So top level properties would be when you first get this Pokemon, everything that you see in the shallow level. And then made another one with stat properties. So I said, okay, I'm gonna maybe you could make another one for moves, right? You could check moves or those deeper properties a little more aggressively. So yeah, that could be a pattern, right? So like one for stat properties, one for move properties, one for game indices, whatever, however deep you want to go. But it can be all very concise. So just write this once, and then here um, you can, if you want to check all the Pokemons, it takes a while. So I'm just going to check 1 to 10, and we're using for each because this is a test. It's fine. So get Pokemon, so that gets Pokemon by ID. I guess there's a better name for this, right? Or you could say just, I mean, it's understandable. So you're getting it by ID, and then you're passing all those top level assertions into Spock. And then you see, you're basically doing the same thing, right? We're yielding the stats, and then we're checking each stat. All we're doing, I mean, we did the same thing up here. All we did here is just we push in the stat props, and that is exactly the same thing, right? And then let's do that. So basically, this proves out that the assertions we have here aren't super specific, but they are so much, right? I mean, it's what let's see, 13. So that's like 30 lines of assertions. But with 30 lines of assertions, just only 30 lines of assertions, you can test thousands of lines of data. And that proves that, okay, you got some decent assertions there that generally works for many, many, many things. And you can just keep increasing this. And at some point, we will probably see something like, hey, this part didn't uh, satisfy it. And then maybe, I mean, usually you're not going to have to do, I'm just going overboard here, but usually you're not going to have to, but it's just a good balance between not being too specific and having good enough assertions that you have full confidence in your data, in your schema. It's not only your schema, obviously, right? You can check the schema too, but you can go a few levels deeper. The biggest strengths are, I think, the predicates, being able to uh, add assertions with your predicates, and then being able to chain in further, right? And then make even more, even lower level assertions on everything. So this repo, I'll I'll put the link. Um, it, it's quite awesome. If you're doing API testing or any other, like API testing pillars are cy-API, data session, and cy-spok, right? All of them from Gleb Bahmato. Hats off. Um, can't live without any of them right now because this just takes things to the next level. That's all I had to say, and it's been a long video, but got a lot to talk about. All right, later.